Good morning and good afternoon to you all. Yeah, once again, welcome to our session, our learning session on database modeling and design with SQL. I hope you can all hear me.
Yes.
Okay, thank you. So from the previous sessions, we've been looking at the database design process. We talked briefly on requirements gathering, then we came to the conceptual design. With the conceptual design, we've been looking at designing your model with mainly the entity relationship model. We've looked at some other ways of coming up with your model, but we'll focus mainly on the entity relationship model. Then we move on to the relational data model, which would fall into the logical design. So today we are going to the attributes and the different types of attributes, when to use which attributes, and then we'll move on to relationships in the next session. We'll still be using our company scenario database, and still on the employees. From last time, we identified a number of attributes for the employees. That's just for demonstration purposes. So for the employee would have an ID, a name, a date of birth, the sex, and the phone. Anytime you create your model or the schema for the table, then you now be looking at how to populate the database. So this time we have some sample random data that we use to populate our table. Okay, let me just push this to the side. Okay. Our table, 5 data sets or 5 rows of data that we are using to populate our table. Now, for each of these data sets, you'd realize that they have a certain pattern. So for employee ID, integers. So it's mainly 0s, 1s, 2, 3, 4, 5. Names are a set of characters. The date of birth has the format of a date. The sex has mainly two values, either male or female. Phone is a set of numbers also. So each of these would determine what kind of data would be stored for a particular attribute. Now, this is very important when you are creating the database, because this would help you to collect the right kind of data into your database. There are a lot of cases where you have people populating databases with inaccurate data or data that is not valid. Anytime you put in invalid data, you would come out with invalid data also. Garbage in, garbage out. When your database is full of inaccuracies, the reports that will be generated out of your database will also be full of inaccuracies. So always make sure that the database that you are designing is collecting the right kind of data. So for employee ID, we'll say the data type would be int for integers. For our name, the name is for varchar. We'll take the data type varchar. Varchar, which represents varying characters. Varying because we don't have a specific number of characters for a name. Someone's name could be 10 characters, someone's name could be 15 characters. So because the number of characters that would form the name would vary, so we'd say it's varchar. We need to indicate a limit for the varchar when you are designing the database. So for example, if you say varchar 20, that means the values for name should not exceed 20. Date of birth would obviously take the date format. And this depends on the DBMS that is being used. For MySQL and SQL Server, normally the date format is the year, month, day. The year takes the 4 numbers. So YYY, YYYY, then the MM, then the GD. Oracle takes a different format. It uses DD, MON, and the RR. So for Oracle, the month portion uses the first 3 characters of the month. So it depends on the DBMS or the software that you are using to manage the database or to create the database. SEX, in this case, we are using what you call an enum. Enum is for enumerated characters. With enumerated characters, you specify the characters or the set of values that can be accepted for a particular attribute. So here we can just say that for sex, we are only accepting male and female, and it takes that. If in other jurisdictions, you could include other values, data values for the sex. Then phone number, we say we are using car for this one. Why do we say car when phone number is supposed to be numeric? It's car because we would want to consider the country code. So when someone is entering the country code for the phone number, you add the plus. When you add the plus, the integer cannot take it. So we need to change it to car to be able to accept it. Someone will ask, what's the difference between the car and the var car? The car takes a specific number of characters, whilst the var car takes a varying, it takes a varying set of characters. So for phone number, if we say car 10, that means the value should be 10 digits or 10 characters. But if we say var car 10, that means the value should be up to 10 characters. Okay, then department will also be var car, which is a set of characters. All these are the data types. Once again, I'm saying that the data types are very important because they indicate what kind of data you are storing in the database. Now, when you are designing the database, the designer or the data architect doesn't just sit down to determine these data types. He does that in consultation with the users of the database, the product owner, the developers, and all of the other people. Because let's say, for example, the employee ID. The data architect wouldn't know the format for employee ID in an organization or in a company, especially if he is not with the organization. It's very important to collaborate with the users and know how to capture all these data. It's very important to make your database valid, to make it accurate, and to make it relatable also. Now let's look at some types of attributes. The first one that we'll be looking at will be the composite and the simple attribute. Composite attributes are composed of several components, whereas simple attributes are single or atomic, or they cannot be broken down. Composite can be broken down into simple attributes. An example of composite attributes would be name. Why do we say name is composite? Composite because we can further break down the name attribute into either a first name, middle name, and a last name. Why do we need to look at this? When you are designing your model, the name would be acceptable when you are doing maybe the entity relationship model, or you are just designing it on paper. But when you are transferring it into the database, it's necessary to break it down into single or simple atomic values. For relational databases, that is one of the requirements. If you don't do that, your database would not meet the normalization requirements. So it's very necessary for the relational databases. Another set of attributes that we look at, we call that the multi-valued and the single-valued. Multi-valued attributes take multiple values, whereas the single-valued accept only a single value. An example would be the phone number. So phone number would be could accept multiple values in the sense that someone could have a mobile phone, a work phone, a home phone, and all of that. So when you ask for phone number, the person may be tempted to produce all 2 or 3 phone numbers. That would mean that that attribute can accept 3 phone numbers. But when we take the single valued for an attribute, an example is age. if you're filling a form and someone asks for age, I'm not too sure that people would write two values for age, unless maybe you're a footballer and you want to cut down your age or something here. But in most cases, age is just a single value that you put there. So that's the difference between the multi-valued and single-valued. For relational databases, it's always important to use single-valued attributes instead of multi-valued attributes. The third set that we look at is stored and derived. Stored attributes and derived attributes. Stored attributes are physically stored in the database, whereas derived attributes are derived from another database. An example of a stored database would be the date of birth. So date of birth will be stored in the database, but we can derive the age from the date of birth. So in certain instances where maybe you're filling a form and in the physical form or in the paper form, they request for age. When you are transforming this onto the electronic database, it will be prudent to use date of birth instead of age, because you can always derive the age from the date of birth rather than storing age. Because when you store age in the database, after every year, you need to perform an add date and add +1 so that your data will be current. So it's always easier to store your date of birth, and you can always derive the age from your date of birth. Then one last attribute that we'll be looking at. Let's take this. Phone number can be broken down into 3 components. You could have the country code, you could have the network operator, then you could have the number itself. That makes phone number a composite attribute. Remember composite, we said it could be broken down into single or atomic values. Now this same phone number, one person could have a mobile number, a home phone, and a work phone, and that makes it multi-valued. A combination of these two is what we call complex attributes. A combination of both the composite attributes and multi-valued are called complex attributes. Now, all these, we are looking at it because we need to understand how the attributes collect data or how they store data. Then you know how to represent them in your database. If you don't understand it very well, it would not make you design a good database. Okay. I think there's a question here. Okay, so someone is asking for permission to record the class. The session is actually being recorded, and the link would be sent, the link to the YouTube video will be sent in the Agile Transformation group. So you can just use the link in the chat to get updates on the slides and on the video recordings, even for the previous sessions too. Okay. Let's look at key attributes. This type of attributes, even with the name, is very key in every database. A key attribute is an attribute of an entity with a unique value. So for all key attributes, their values are unique. It uniquely identifies a row of values or an entity, and a typical employee of the employee entity. So for every employee, you would have a unique employee ID. No 2 employees would have the same ID within the same organization or within the same company. These key attributes, it's very essential. If you don't use a key attribute in your database, you are likely to have duplicates in your database. When your database starts having duplicates, that means that your data is not very reliable. So you should implement this key attribute in your database. And it's actually one of the requirements for normalization or having a quality set of data, a key attribute. They are represented in two ways when you are designing the model. You could find that the attribute is underlined. So when it's underlined, it shows that it's a key attribute, or some people use the PK to represent primary key to show that that is the key attribute. Then some people use some systems use the key icon to represent the key attribute. So in any system, when you find one of the attributes underlined or one of the attributes with the key icon, then it shows that that is the key attribute. Now for the key attribute, the value cannot be empty. It always has and we are saying that it's unique. So if there's an entry and so for example, for the employee ID, if there's an existing employee ID and someone tries to enter the same employee ID for that attribute, the system is supposed to reject it. If your system accepts the same ID twice from different people, then your system doesn't have, or your table doesn't have a key attribute. And normally when your database is like this, it is not very good, it's not very reliable, and all of that. You need to always check for your database to be sure that it has a key attribute. Now, the thing about the DBMS, or the software that you use to create the database, it won't force you to create the key attribute. It assumes that you know what you are doing. So if you create your database and you omit the key attributes, it will just allow it. All that would happen is that when there are any duplicate entries, it will just accept it. And that would be like using a spreadsheet software. But we are saying that one of the advantages of database over the spreadsheet is that it tries to avoid these duplicates. So you need to structure your database well to avoid these duplicates. A key attribute, or an entity may have more than one key. An example could be the student. So for a student may have the student ID, or the student may have a student email. In both cases, these two would be unique. So a designer can decide to use any of them as the key attribute. In every system, there should be one key attribute. So it's at the discretion of the data architect to select either the student ID or the student's email. There are certain times that the key attribute may be composite, in the sense that, let's say, for example, the student ID once again. The student ID for some schools may have a year component, the program component, and the number component. So if the student ID can be broken down into sub-components, that makes it composite. Or sometimes it could be a combination of two attributes to form the key. That is called the component. That in the subsequent sessions. Yeah. So two things about the key. An entity may have more than one key within the same table, or the key attribute may be composite. Okay, so that is it for our session today on attributes. So for today's session, we'll be looking at attributes. We talked about the data values that go into the tables, and each attribute is supposed to have a specific data type. We mentioned the integers, the characters, either the specific characters or the varying characters. We mentioned the enum, the date, and all of that. Then we also talked about the various types of attributes, the composite and the simple attribute. We talked about the multi-valued and the single-valued. We talked about stored attributes and the derived attributes. And we said that a combination of the composite and the multi-valued attributes form what you call the complex attributes. Then the last one that we talked about is the key attributes, which is the unique identifier for every entity within the database. So the value for the key attributes should always be unique. It helps to eliminate duplicates and it gives you a structured database. So I will take if there are any questions or discussions or any feedback on the session, we would take them now before we close the session.
Hi, Carlos.
Hi, Owen.
Thanks very much for this session, man. Simple, straightforward, and very, very accessible. But I've got a question here.
Yeah.
You know, when you were talking about the types of the attributes, yeah, the composite and the simple, yeah?
Yeah.
On the slide you presented, for composite, you said it's composed of several components, and you gave an example like name, you could have like first name, last name, yeah?
Mm-hmm.
And then for simple, that's right, you said it has to be single, atomic values for the attribute, okay? And then you said example, first name, last name, but if it's simple, it's supposed to be a single, why would it be first name and last name?
Okay, so the first name and last name is not together. So the demonstration I'm doing here is that name can be split into first name and last name. So instead of having name as one attribute, you would have to split it into two attributes to have first name as a single attribute, then last name as also as another attribute. So we are not combining the two in one attribute or as one attribute.
Okay, got you.
Now this is important because it makes, so we have some data sets where in the first instance, everything is combined. When you're trying to generate reports and you're trying to derive only the last name or the first name from the data set, then you need to perform some operations or use some delimiters to extract the data. But when you have it separate, first name separate, last name separate, you could always put it together by using the concatenation when you're generating reports. So it's always easier to have it in single atomic values and put it together when you're generating reports rather than having it together as composite. Then when you want to generate it individually, it becomes a problem. Yeah.
Just one last one, please. Yeah.
Okay.
You know, when you talked about the key attribute, yeah. Now, I'm just a little unclear on, is it the data architect who will now decide to determine which one is going to be the key attribute? I mean, what criteria would you use for saying, okay, this is going to be the key attribute, you know?
Okay, so during the requirements engineering stage where the team meets to discuss about all these requirements in an agile environment, you realize that everybody brings their input, they collaborate, and they come to a common understanding. So it's not just the data architect or the database designer that sits down and decides that this would be the key attribute, because you need to understand what happens on the system or in the organization to know that, okay, for this value, this is going to be unique for everybody. Then you can now say, okay, then we can use this. If there's no natural primary key or key attribute within for a particular entity, then there's something we call the surrogate key or the artificial key that could also be used as a key. That one is system generated. So it's like the first set of values that goes into the database becomes ID1, the second set becomes ID2, and that kind of thing. So it's not just the database designer or the data architect that decides on whether this should be the key or this should be the key.
Thank you very much, Carlos. Thank you very much.
Has a question. It says attributes that have potential uniqueness such as ID and email, should that not be made mandatory that these are primary keys? Yes, they should be mandatory. It depends. You know, so for certain entities, so let's say the student entity or even the employee entity, and the employee would have an employee number or an employee ID. The same employee would have email. These two are unique. Every employee would have a unique ID. Every employee would have a unique email. you can't use the two as the primary key. You need to decide on one because the relational database would just take one of them. So in that case, then because of that, you just look for, there are certain recommendations. For example, it's easier to use the values that are numeric or that or those smaller in size. Yeah. So it's good, yes. But what I need to say is that most primary keys or all primary keys are mandatory. They should take a value. They cannot be null. When I say they cannot be null, the attributes cannot be empty or the value cannot be empty. So in a form where maybe you are filling an online form, those ones would mainly be the required ones. Always the key attribute would have to be required. It has to take a value. So they are mandatory, yeah.
What of a situation where, like you said, one of the key characteristics is that it should not, that value cannot or should not be duplicated or should not have a duplicate value. Yeah. If an email, for example, is taken as the primary key, and which would be represented as, let's say, first letter of your name, surname, at whatever the work email is or whatever. You see what I'm saying? You find out that you could have a lot of people with a similar sort of first letter and the same surname. So that would create a duplication, and that would not be a good idea to use as a primary key.
Okay. So when that happens, the two people cannot have the same email account. So when that happens, what would, when the system takes the first person, the email address, and the second entry is being made, even if it is not the primary key, the email will be set to unique so that no two people would have the same email address or email account. Even if it's not the email ID, it's not the primary key, it would be set to unique. Unique works the same way like the primary key. So sometimes some people use maybe numeric differentiation. So you'd have the second person would have the same email, but with the number 2 or 3 or 7 to differentiate between the two emails. You would not have the same two email accounts with the same name. No, it's not acceptable in relational databases.
You don't have to hire.
Yeah. Right. Thank you.
Because the causes of the coronavirus, they could be.
Any more questions?